So M&M's brown, yellow, red, blue, orange, and green. And I remember when I was a kid, the red M&Ms disappeared for a while because it turned out the dye they were using at the time was slightly radioactive. That explains a lot. All right, so we have 12% here, and then 15% for yellow. Red has a 12% probability, blue a 23% probability, orange also 23, and then green is 15%. And let's just double check, always a good idea that these add up. Partly it's just to make sure I copy them correctly. So we have 5, 7, 14, 17, 20, ooh, does that add up? 5, 10, 20, oh it does, I just misdid it, carry the 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that adds up to 100%, we're good. So then we're asked to do some probabilities. So the probability of not green. So compute the probability that a randomly selected peanut M&M is not green. And the random selection is important. So there's two ways to solve this problem. One way is to just add up all the not green probabilities. The other is to use the idea that I talked about the other day, 2 days ago, is that the complement of green is not green. So that's equal to 1 minus the probability that it is green, which would be 1 minus 15%, which would be 85%. To check that, we could just add up all of these other ones, 12% plus 15 plus 12 plus 23 plus 23, and see what it adds up to, because those are all the not green options. But the point of this one was to think complementary probabilities, 1 minus its complement. So 85% for that one. All right, that wasn't too bad. Compute the probability that a randomly selected peanut M&M is brown or yellow. So again, we have a single randomly selected M&M, probability of brown or yellow. And whenever we have an or, we have to wonder, ooh, what if it's brown and yellow? Okay, now that wasn't given as a possibility, so I'm assuming it can't be brown and yellow at the same time. So that should be equal to the probability of being brown plus the probability of being yellow. So in this case, what do we get? Brown is 12% plus 15% is going to give us 27% chance that can happen. Let's see, and it looks like I typed a number in here before. Get rid of it just for fun. Oh, by the way, these are given in percents. If a probability does not have the percent symbol outside the box, you got to enter it as a decimal. So for this one right here, I would have to enter 0.85 to get the right answer. Compute the probability that 3 randomly selected peanut butter M&Ms are all brown. Now, here we don't have like how many M&Ms there were to start, so we're assuming there's like infinitely many M&Ms to start with, because we don't have like a total number of M&Ms in a bag, for example. So in that case, because I don't have something that, to start with, I have to assume that they're independent. So the probability of getting 3 brown, again, assuming this is independent, then that would just be to multiply the probability of brown by itself. So probability of brown times the probability of brown times the probability of brown. So that would be, oops, 12% times 12% times 12%, or 12% cubed, which looks kind of weird. see, what was the answer format looking for? Oh, I could actually type 0.12 cubed, probably get it right, but I probably should figure out what that number is. Calculator. There's a pretty small probability, so 0.01728. So less than a 1% chance of happening. That is a decimal, not a percentage. So that would be an appropriate answer we can type in. All right, next one. If you randomly select 5 peanut M&Ms, compute the probability that none of them are orange. Okay, so this is kind of similar. Probability no orange out of 5. So I think the way I would do this would be 1 minus the probability of getting 5 orange would be the easy way to calculate this one. So that complementary event idea can be pretty handy. So then that would be 1 minus the probability of an orange is 23%. We have to put it as a decimal. And that would be to the 5th power. So the probability of kind of like getting 3 brown, the probability of getting 5 orange would just be 0.23 to the 5th. So then everything else must be no orange. Is that true? Ooh, no, that's not true. I lied. Anybody see a flaw in this right here? So the flaw I see in this right here is here I'm only counting exactly 5 oranges. But that doesn't count, say, getting 1 orange and 4 of something else. But this says no orange out of 5. So it turns out my first thought on a shortcut on this is incorrect. All right, so let's rethink that. Probability, make sure I read that right. If you randomly select 5 peanut M&Ms and compute the probability that none of them are orange. Okay. Yeah, so my first go at that would have definitely been wrong. So the probability of no orange out of 5. And so that would mean, right, I have a first one I pick, I have a second one I pick, I have a third one I pick, I have a fourth one I pick, and I have a fifth one I pick. I'm not going to make a tree for this. I don't think it's necessary. But the first one can't be orange, so no orange in the first one. And the second one, that also can't be orange. No orange for the second one. And the third one can't be orange either. I'm just going to abbreviate that, no or. That's the third one. The fourth one, that can't be orange either. No orange. And the fifth one can't be orange. So now I just need to know what the probability of getting no orange once, and then I need 5 of those multiplied. So if we look back at our probability table, orange is a probability of 23%. So not orange would be 77%. So each of these is 77%. And I have 5 of them multiplied out, so that should be 77 to the 5th power for no orange. Does that seem reasonable? And that should be not quite as high as the other probability I found, which takes into account every spot can't have an orange. So I can't have 1 out of 4 orange, I can't have 2 out of 4 orange, every spot has to be a no orange. calculator. So that would be about a 27% chance that that could happen. So 4 decimal places is probably enough. 2707.
And how did you get 77?
So I want to know what the probability of no orange is, which is always going to be 1 minus the probability of getting an orange. The probability of an orange was 23%. So what's 1 minus 23%? That would be 77%. All right, looking back at the table, there's a 23% chance we get an orange. Not getting an orange would be 100% minus that, which would be 77%. Good question. Other questions? Looks like there's one last part. If you randomly select 5 peanut M&Ms, compute the probability that at least one of them is orange. Probability at least one is orange out of 5. If you randomly select 5 peanut M&Ms, compute the probability that at least one of them is orange. Okay, so what does that mean for us? So at least one is orange. So I could have orange and then red, 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 red. But I could not have all reds. I could have 2 oranges, I could have 3. So it could be orange, orange, at least one, even could be all the way up to all orange. So or 2, 3, 4, 5. But we can't have no orange. So does it seem reasonable that the only thing we can't have is no orange? So think about that for a second. Another way to state that is that the complement. So what is the opposite of at least one? I think it's none. Right? I could have 1 orange, I could have 2 orange, I could have 3, 4, I could have 5 orange, but I can't have none. Can someone give me a thumbs up on that, or no idea what you're talking about? Okay, Avali gives me a thumbs up, okay. So I think that seems reasonable. So if this is really the opposite, having a none, then the probability of at least one orange should be 1 minus the probability of no orange, which is what I tried to accidentally do before. So the probability of not having an orange, remember that is, let's see, 77%. Kind of like what I did before. Yeah, so the probability of having one of them not be orange, one not orange, is 77%, because the probability of having a single orange is 23%. And this is no oranges out of 5. So that should be 1 minus 0.77 to the 5th power. Otherwise, we have to find the probability of having only 1 orange, then find all the ways we can get only 2 oranges, then find the way of only 3 oranges and 4 oranges. This one right here is too much work. I estimate it would take me an hour to figure it out that way. Yep, this seems reasonable right here. Let's see what that is. Calculator. Well, that's the opposite of this one right here. So 1 minus that answer above. So that should be about 72.93%. All right, so again, at first glance, these problems don't look that bad, but I mentioned somebody can easily ask a probability question that can really stump people and make you think really hard. And sometimes they are like super impossible. Not super impossible, but super hard. All right, I think that is enough for probability. Covered all the big stuff. Let me just double check that homework assignment.